This is Unit 5, Lesson 4. We're doing more rational exponents and radicals. In this one, we're going to go back and forth even more with the radicals and the rational exponents. So with this, notice they both have the same base of a 5. So I can convert these to fraction exponents. The square root of 5 cubed is 5 to the 3/2 times the square root of 5 to the 5th is 5 to the 5/2. And now, since my bases are the same, I'm allowed to keep the base and add the exponents. 3/2 plus 5/2 is 8/2 or 4. So that's 5 to the 4th. 5 to the 4th would be 625, and certainly you could use a calculator to figure out what that number is. For this one, we've got 7 underneath the 5th root, and it's 7 squared underneath the 5th root, and here we've got 7 cubed underneath a square root, and with this one they are giving us 4 choices for our answer. So what I would do, and they've expressed some of them as powers of 7, some of them as powers of 49, so how we interpret this problem is going to depend on how we can simplify. So I know that 7 squared underneath the 5th root is the same thing as 7 to the 2/5. I also know that 7, the square root of 7 cubed, is 7 to the 3/2. So if I have converted those to fraction exponents, now I can keep the 7, keep the base, and add my exponents. So I have to add 2/5 plus 3/2. And 2/5 plus 3/2 is 19/10. Notice I did that on my calculator. I can't do that in my head. I mean, I could do it with writing some things down, but there's no need. You can use a calculator for that kind of computation there. So we've got 7 to the 19/10. Well, does that match anything? Doesn't match that? It does match this one. So I would say B would be the right answer for that one. A lot of times with multiple choice answers, you're not going to know exactly what you need to do to solve the problem until you actually look at the choices that you've been given. Here I have 4 more examples, and for all of these examples, the directions are going to be to find A. So we're going to use what we know about fraction exponents and rational exponents to find what A is here. And you'll see that you've got an expression on the left equals an expression and x to the a on the right, and our job is to simplify this expression until we get a base of x and we figure out what that is, x to a power, and that power will be our answer. So if you look at the first one, the top says, or the 6th root of x to the 5th, we can rewrite that as x to the 5/6. That is over x to the 1/5 to the 6th power. Well, that 6 is on the outside of the parentheses, so that means we can multiply the exponents together. So that would be x to the 6/5 if I do 6 times 1/5. And then if I want to simplify that, I want to get x by itself. And in order to figure out what the a is, or the exponent is, I would take 5/6 minus 6/5. 5/6 minus 6/5 is negative 11/30. I did that on my calculator. Now, that is a negative exponent, but it's okay in this case to have a negative exponent because all they were asking for is what is the value of A. A here would have to be a negative exponent if we have an x that stands alone to a certain exponent. So it would have to be negative in that case. In this one, I've got x to the 1/6 times the 6th root of x. Well, the 6th root of x needs to be converted to a power of x. So we've got x to the 1/6 times x to the 1/6. And I want to figure out what my a value would be. Well, in order to do that, x to the 1/6 times x to the 1/6, I keep the base and I add my exponents. So 1/6 plus 1/6 is 2/6, which is 1/3. So on the left we have x to the 1/3, so that means A is 1/3. In the next one, I'm going to rewrite this as x to the 2/3. Multiply those powers together because the power is on the outside of the parentheses. And then this one is times x to the 1/3 And then I have the same base. They are multiplied together, so I keep the base. I add my exponents. 2/3 plus 1/3 is 1. So A, in this case, my answer would be 1. So if it's a fill-in-the-blank question, I would just fill the blank in with the number 1 because that's what my A value is represented by. For this one, that is x to the 1/5 over, this is x to the 4/5. And again, in order to find the power of A, we would take the top exponent minus the bottom exponent. That would be x to the 1/5 minus 4/5 would be negative 3/5. So again, you would have a negative exponent. Negative 3/5 is what A would be represented with.